Well, hey guys, Mr. Roden here. Um, yesterday I talked about maybe doing some math basketball to practice this stuff. Um, and but here's the deal. I apologize. I have Mr. Sansoni's class in my fifth period, and what I want to do is just hold off on math basketball. I know that a lot of you want to play. Let's hold off until Mr. Sansoni gets back, and then his class. That way, we can just have our class. So I'm going to hold off on math basketball, but it's not a punishment to not play today. It's just Mr. Sansoni is not in today, and we're helping him out. So I'm going to ask you to watch this video and just practice these things. You also do have Delta Math. It's called 1.3 in your Delta Math. And what I'm doing is I'm just going through and I'm just doing a bunch of examples that you might see in your Delta Math tonight. Okay. All right. So let's go ahead and take a look at this. Now, remember what we have. We have, and again, this is Mrs. Peterson. Shout out to Mrs. Peterson. Don't call me after midnight. And then we could actually sound like a game show. Don't call me after midnight. That's kind of, you could say it like that. So remember what don't call me after midnight stands for. D in don't stands for the distributive property. So you want to eliminate your parentheses using the distributive property first, if there's parentheses. Next, you want to collect all your like terms. M stands for move the variable to one side. A stands for eliminate addition and subtraction. And M stands for, the last M stands for eliminate multiplication and division. Now, towards the end of these problems, we may come up with some really funky things that happen, and I want to talk about those a little at the end. All right, so what I'll do is I'm going to work a problem just now, and I just want you to write this down. So go ahead and write this problem down, number one. I believe I have 8 examples here I want to show you. So go ahead and write number one down. Maybe pause the video to write it down. And then I'm going to work it out, and let's just follow along with me, and then you can work the next one on your own. Okay, so we're going to use don't call me after midnight on each one of these. So the first thing we have is D, distributive property. Well, I don't have any distributive property because there's no like terms. Okay, there's no like terms. So there's no distributive property. So what about collecting like terms? Well, there's no collecting like terms. I don't have any on the same side. I have a 5x plus an 8, and those are different terms, and I have a 2x minus 19. Those are two different terms. So I do not have any like terms on the left side or the right side. So now the next thing I need to do is I need to move the variable to one side. Now I'm noticing I've got a 5x on one side and a 2x on the other side. I don't want that. I want them all on one side. So I like to, what I say, attack the weaker variable. Now some of you like to attack the stronger variable, and that's fine. You can still get the same answer. It just, I like to attack the weaker one because I won't have to divide by a negative if I do that, but it's up to you. So I'm going to subtract 2x's from both sides. I'm going to subtract 2x's from both sides. Well, when I do that, that's going to eliminate 2x on the right side, and all I'm going to have left over on the right side is negative 19. On the left side now, I have 5x minus 2x. That gives me 3x plus 8. Now I'm done with distributive property, collecting like terms, move the variable to one side. Now I'm on the A part, after. Well, what do? Let's see here. I want to eliminate my addition and subtraction. So what am I adding or subtracting to this equation, this x? I'm adding 8. So I'm going to subtract 8 from both sides. I'm going to subtract 8 from both sides. Now, this is where a lot of you messed up on your quiz. I would suggest doing a negative and positive chart, even though you don't think some of you need it. So I'm going to put a 19 under the negative, and I'm also going to put an 8 under the negative. We're on the same side of the chart. You add and keep the sign on top. Well, what's 19 plus 8? I believe that is 27. And since the negative's on top, it's going to be negative 27. So I get 3x equals negative 27. And then what I'm going to do on both sides is we're going to divide by 3, because that's the last thing, is we're going to eliminate multiplication and division. Well, what do I do after that? 3 cancels 3. That's a spooky one right there, right? That's a spooky one. We don't need to write it. A negative divided by a positive is a negative, so that's going to be a negative. and 27 divided by 3 is 9. So my final answer is negative 9. All right, so go ahead and see if you can't do number 2 on your own. So pause this. When Mr. Roden's walking around, he should see the video paused, and you're working number 2 on your own and see if you can get it right. Hey, welcome back. So hopefully you got this right. Let's see how I would do it. Remember, I'm going to do don't call me after midnight. So the first thing is I'm going to look at is distributive. Ain't got any distributive there. Ain't's not a word. Don't use ain't. But they don't have any distributive word, right? Distributive property there. What about collecting like terms? Nah, there's nothing on the left or right we can collect. Let's move on. Me. Okay, so this is where I need to move variables to one side. Well, I've got a negative 2x over here, and I've got a 3x. And Mr. Roden always likes to attack the weaker variable. That's how he does it. Well, negative 2 is weaker than 3, so I want to make a negative 2x into a 0. How do I make a negative 2x into a 0? I add 2x to both sides. I add 2x to both sides. See what I'm doing here? If you have negative 2x and you add a positive 2x, those cancel out to 0, and we do not need to write the 0. It's gone. So now we just have this negative 6 on the left side. Now, what do we have on the right side? 3x plus 2x is 5x. So we have 5x, and we still have the minus 21. Okay, so now we've moved variables to one side. Now we're going to go ahead and eliminate addition and subtraction of the variable. Well, I'm subtracting 21, so now I'm going to add 21 to both sides. I'm going to add 21 to both sides. So the 21s cancel. So now I get 5x equals, now I'm going to do the math. I'm going to do a little chart over here. Maybe you need it, maybe you don't. I always like my chart. So my 6 is negative, my 21 is positive. When they're on different sides, we subtract 21 minus 6. What's 21 minus 6? That's 5, right? 21 minus 6 is 5. So now I get 5 on the left side. Now I'm going to eliminate multiplication and division by simply just dividing both sides by 5. And of course, 5 divided by 5 is 1. Now, a lot of kids are like, Mr. Roden, I don't need to write that one. Well, that's that one on the other side. That's not a spooky one, okay? The one next to the X, yeah, that one right there that I'm kind of highlighting right there, that's a spooky one. But the one over here, that's not a spooky one. You actually have to write that one, okay? So your final answer would be X equals 1. All right, let's try another one here. Okay, so let's do don't call me after midnight. All right, so go ahead and try this one on your own and see if you can get it right. Negative 10x plus 5 equals negative 2x minus 35. I always say if you can get 2 in a row right, you probably know what you're doing. Maybe you just got lucky on the first one if you got x equals 1. But if you get this one right, number 3, you'll know that you know how to do it. Okay, welcome back. So now what I'm going to do is, well, don't have any parentheses, can't collect any like terms. I'm going to attack the weaker variable. Well, which one do I want to attack? I think I want to attack the negative 10 because negative 10 is weaker than negative 5. It's further to the left on the number line. Negative 10 is weaker than negative 6. Sorry, I said negative 5. Negative 10 is weaker than negative 6. So I'm going to attack the negative 10. How do I make a negative 10x into a 0x? I just simply add 10x. If I add 10x to the left, I've got to add 10x to the right. Got to be fair, right? That's the whole thing about a fairness bar. You got to be fair. So the 10x cancel. When I do that, I just have that 5 left over on the left side of the equation. Now, what's negative 6 plus 10? Let's see if we can do that one in our head. Well, that's the same as 10 minus 6, right? And it's going to be positive. So that's going to give me 4x, positive 4x, minus the 35. Okay? So now we've moved variables to one side. Now we're going to take care of eliminating our addition and subtraction of the variable. Well, I'm subtracting 35, so the inverse operation of subtracting 35 is adding 35. So I'm going to add 35 to both sides. 35 plus 5 is 40. So I get 40 equals 4x. Now I'm simply just going to divide both sides by 4. And so 4's cancel. There's your spooky one. So you get x equals 4 goes into 40 10 times. So your answer is x equals 10. Did you get it right? Give Mr. Roden right now, if you got that correct all by yourself, give Mr. Roden, just give him a thumbs up. Just just kind of look at Mr. Roden, and while he walks around, give him a thumbs up, and he'll be like, you know what? He might even give you a JAG book. I'm telling you right now, if you can give him a thumbs up and you can show it to him, he'll probably have a JAG book waiting for you, and he'll slap a JAG book on your desk if you can give him a thumbs up that you got it right. Now you had to get it right all by yourself. Okay, sound good? All right, so give him a thumbs up, and he'll give you a JAG book for that one. Let's see how many kids are actually listening to that. All right, so remember, guys, what we're doing on this. Let me kind of give myself a little bit more room here. Get this out of here a little bit. Okay, remember, we're doing don't call me after midnight. Don't call me after midnight. Okay, all right. So the first thing we're going to do is distributive property. Oh, we've got some distributive property here, don't we now? Oh, okay. All right, we got some distributive property. So I'm going to take this -2 and I'm going to distribute it through here. See what I'm doing here? So I'm going to take -2 and I'm going to multiply it times the 3x. -2 times 3x is -6x. Now I'm going to take the -2 and multiply it times the -4, and that's going to give me a +8. 2 times 4 is 8. Negative times the negative is a positive. And then I'm just going to recopy the -x minus the 3. So I am done with distributive property, and that still equals 33 on the right side. Okay, now I'm on collect like terms. Well, on the left side of the fairness bar, I'm noticing that I can take -6x and subtract 1x. What's -6 minus? Now think about that. So we have negative positive chart. You've got a -6, so it's negative, but you also have a spooky one that's negative over here. So that's 1. So 6 plus 1 is 7, and it's negative. So now we have -6x plus. What's 8 minus 3? Well, 8 minus 3 is 5. So we have -7x plus 5 equals 33. So now I've collected my like terms. Now, the first M stands for move variables to one side. Well, I don't only have an X on one side, okay? I don't have an X on the other side. So what I'm going to do now is just move on because I don't have to do that step. That's in this problem, I didn't have to do that step. That's okay. You don't always have to do every single step. You just need to make sure you're kind of running this list. The next thing you're going to do is you're going to subtract 5 from both sides because we're eliminating addition and subtraction. All right, so now we have -7x. Now, what's 33 minus 5? And I believe that is 28. And the last step we're going to do is we're going to eliminate multiplication and division. So we're going to divide both sides by -7. So a positive divided by a negative is a negative, and 28 divided by 7 is 4. So my answer equals x equals -4. And I'm done. All right, I want you to go try this number 5 on your own, okay, and see if you can get it. Number 5 on your own. You're paused. Go ahead and pause me. Pause me. All right. So at the end of this one, give me a thumbs up if you got it, and show Mr. Roden on this one. He'll probably slap a JAG book on your desk if you can get this one right all by yourself. Okay, so let's do it. Well, don't call me after midnight. Remember, that's our saying here. D stands for distributive property. So I do have distributive property because I have parentheses. So I'm going to take that -3 and I'm going to distribute it across the parentheses. Now, when I do that, I get -3 times 2x. That gives me -6x. I get -3 times -3. That gives me +9. A negative times a negative is a positive, and 3 times 3 is 9. Still have the plus x, still have the plus 4, still equals -27. You with me on that? So now I'm done with the distributive property. The next thing I'm going to do is I'm going to collect like terms on each side. Now on the left side, this is the left side, remember class, and this is the right side. On the left side of the fairness bar, I can collect like terms. Which ones can I collect? I can collect the -6 and I can collect the positive x. Be careful here. Maybe a chart could be helpful. Negative, positive chart. 6 is negative. Now there's a spooky one, but it's a positive spooky one, right? When they're on different sides, we subtract. SUB stands for subtract. 6 minus 1 is 5, but the bigger one wins. The negative wins. So this is going to be a -5x when you combine -6x plus x. So this is going to be -5x. Now 9 plus 4, that's 13. And that still equals -27. All right, now the next thing I'm going to do is I'm simply just going to subtract 13 from both sides. Let me give myself some more room here. Okay, so I'm going to subtract 13 from both sides. When I do that, 13 cancels 13. I'm going to bring down that negative 5x. Let's see what I get here. So 7 minus 3. 7 minus 3 is 2. And negative, hold on. No. Oh, my bad. Sorry, guys. Okay, so remember, I'm going to subtract. So this is going to be negative 27 minus 13. Oh, so I'm going to make my chart, right? So I'm going to make negative positive chart. Sorry, I almost messed up right there. 27 is negative. Oh, but 13 is also negative. So I'm going to actually add these and keep the negative. Man, Mr. Roden almost made a mistake. So let's see here. 7 plus 3 is 10. Carry the 1. And then 3, that's 40. Did I do my math right? 40. So that's going to be negative 5x equals negative 40. Remember, it's negative because the negative was on top. Now I'm going to go ahead and divide both sides by a negative 5. Divide both sides by a negative 5. Those negative 5s cancel. So x equals, what's a negative divided by a negative? A negative divided by a negative is a positive. And 40 divided by 5 is 8. So the answer is x equals positive 8. So if you got a positive 8, go ahead and give Mr. Roden a thumbs up. Sound good? All right. Now, the next problem I'm going to look at is a problem like this. Now, what we have, let's do a don't call me after midnight with some distributive property. Don't call me after midnight. Okay, so let's go ahead and do our distributive property here. And so to clear those out, I'm going to get negative 6x. A negative 6 times negative 5 is positive 30. And then we have negative 5x on this side plus 15. All right, so Mr. Roden always likes to attack the weaker, cannot collect any like terms, right? Make sure I can't collect any like terms on either side on this one. Now, on this one, Mr. Roden likes to attack the weaker variable when he moves them to one side. Negative 6 is actually weaker than negative 5 because it's further to the left on the number line. So I'm going to add 6 to both sides. I'm going to add 6 to both sides. Negative 6 plus 6x cancels out to 0, and now I'm left with just 30. So I get 30 equals negative 5 plus 6. So let's do our chart. Negative, positive chart. 5 is negative, 6 is positive. I subtract. 6 minus 5 equals 1, and the positive wins. So this is going to be a 1x, which is a spooky one. So I'll just say x plus 15. Now I'm not done yet, so now I need to go ahead. I've moved variables. Now I'm going to eliminate my addition and subtraction by just simply subtracting 15 from both sides. So those cancel out. 30 minus 15 is 15, so I get x equals 15. And I'm done. How are you doing on this? You guys feeling pretty good about this? All right, 2 more examples, guys. 2 more examples. Now, we're going to get some funky stuff happening here, guys. So here we go. So what happens on number 7? So pay close attention. On number 7, I'm going to still do the distributive property, okay? And now I'm going to go ahead and do the distributive property. Negative 7 times negative 7, a negative times a negative is a positive. So 7 times 7 is 7 times 4 is 28. So this is going to be positive 28x. A negative 7 times a positive 2 is 14. And I still have the 28x on this side plus 14. Now, remember we're going to do don't call me after midnight. So we did the distributive property, right? Can't collect any like terms on either side, so that's done. Well, now, if you notice, it's a tie for 28x on one side and 28x on the other side. So there's really no weaker variables. So, since it's the left, I'll just go ahead and subtract 28x's off both sides. Now, what happens here, and I told you this was going to get really funky. 28 cancels 28, but 28 also cancels 28 on the other side. And what are you left with? You're left with a 14 on the left side, but you're also left with a 14 on the right side. Okay? So what does 14 equal 14? Yes. Is there ever a time when 14 does not equal 14? And the answer is no. 14 is always equal to 14. So whenever you get something like this, when both of the variables cancel and you get a true statement, a number equals itself, then we're going to call this infinite solutions. This is infinite solutions. And on Delta Math, there'll be a thing that says you need infinite solutions, okay? Infinite solutions. So this is an infinite solutions problem because what happened was your variable canceled out and you got a true statement, and 14 is always equal to 14. So it doesn't matter what you put in for x. This will always be a true statement, okay? All right, let's look at number 8. All right, so number 8, I'm going to give you a better one for number 8. Let's say we had something like this, number 8. Let's say we had 3 times 2x plus 4 equals 6x minus 4. Okay, let's say we had something that looks like this. We'll say 6x minus, let's do this, 12. Just change that up. Okay, so go ahead and do number 8 here. Don't worry about this one up here. And we're going to go ahead and do number 8 and see what we get. So when I do the distributive property here, I get 3 times 2 is 6x. 3 times 4 is positive 12. And then on the other side, I get 6x minus 12. Okay, so I did my distributive. I cannot collect any like terms. After, don't call me, sorry, after midnight. So me stands for move variables to one side. Now notice I've got a 6x and a 6x. I'm going to subtract 6x from this side, and I'm going to subtract 6x from this side. And notice that those cancel out again. But what happened this time? Well, on the left side, I get a 12, and on the right side, I get a negative 12. Is 12 equal to negative 12? No, those are two different numbers. If you look at a number line, they're completely on different opposite sides of the number line. 12 is never equal to negative 12. So this has no solution. This is an impossible problem. It doesn't matter what variable number you put in for x. It can never be solved. So this has no solution, okay? It has 0 solutions. It doesn't say the solution is 0. It has 0 solutions. I think that's how Delta Math will say, how many solutions does this have? 0 solutions. It doesn't have any solutions. It's not solvable. So what can happen on here? This one, you can have 0 solutions because you get at the very end, you get a statement that's never true. 12 is never equal to negative 12. So this would be 0 solutions. Up here, we get a statement that canceled out, but it's always true because 14 is always equal to 14. So this would be infinite solutions. And then all these other problems we got, guys, like x equals 15, these are what we call one solution problems, okay? Now, one solution problems, when you have one solution, you actually need to tell Delta Math what that solution is, okay? So that's what can happen on some of these. You can have one solution and you have to actually say what the solution is, like x equals 15. You could have infinite solutions, and then you just say infinite solutions because it's always true when you have a number equals itself. And then you have no solutions when you have a number equals another number that's not itself. And then you have no solutions, which would mean you have 0 solutions. Okay, hope this was helpful. And now go ahead and get started on 1.3 in your Delta Math. And good luck, and we'll see you. That's due on Monday at 11:59 p.m. See you later. Bye.